Hello and welcome to the e-module on Fire Systems Part 4. At the end of the e-module, you will be able to understand what gas fire suppression and water mist systems are, learn in detail about gas fire suppression systems, learn in detail about water mist systems, know about the maintenance checklists of gas fire suppression and water mist systems, know the service levels to be maintained. Understand the impact on business. Understand top 5 issues or troubleshooting ideas. In the last module, part 3 of fire systems, we learned about two fixed fire systems, sprinkler system and the fire hydrants. In this module, that is part 4, we will continue with the fixed systems and look at two other equally important systems, namely the gaseous fire suppression system and the water mist system in detail. Let's get started. Gaseous fire suppression system or gas suppression system is relatively a new technology and is a term used to describe the use of inert gases and other chemical agents for extinguishing fires. These systems are also known as clean agent fire suppression systems, terms used interchangeably throughout this module, primarily because these gaseous mixtures leave no residue behind and are designed to protect enclosures where there is a need for quick reaction to extinguishing a fire. Gaseous fire extinguishing agents are often used to effectively extinguish fires in special hazards that cannot be adequately protected by water-based fire sprinkler systems. These extinguishing agents are also utilized when the application of water may cause excessive collateral damage or an interruption of critical operations like server systems, art galleries, or delicate machinery, where water can cause more and permanent damage than the fire. Halon was a common gaseous agent used in the past for protecting critical spaces from fire. However, it was later identified as an ozone-depleting substance and its production was banned in 1994. Since then, many other alternatives also have been found to be having ozone-depleting potential and they are still in use pending discontinuation in the near future. In this module, we will also be learning about the water mist systems, which are now finding more acceptability in critical environments. These systems work on the simple principle of reduced droplet size of water, which causes more heat absorption from the area due to the increased surface area covered by the water droplets. Thus, fire is controlled by reducing the heat element or cooling the surrounding area by evaporation of gases and reducing oxygen. Now let's look at what comprises of the gaseous fire suppression system. At a very basic level, the gaseous fire suppression system comprises of the following elements: a gas or chemical stored under pressure, a mechanism to detect a fire and trigger release, the delivery mechanism to deliver the gas into the protected space. In reality, the systems involve a lot of design considerations like the volume of the enclosure, the level of occupancy, the gas tight integrity of the room, safety measures to ensure the gas is not released under false alarms, etc. The gaseous flooding systems come in two basic forms: total flooding, main enclosure or underfloor. Here, the complete enclosure is flooded with the gas and retained for sufficient time to enable suppression and prevent re-ignition. Local application. Applied to specific hazard area or areas or equipment such as in-cabinet or local area systems. The agent is applied directly to the fire in the localized area. Gaseous fire extinguishing systems are used primarily to protect hazards that are in enclosures or equipment that in itself includes an enclosure to contain the agent for establishment of required concentration and maintenance thereof for the required period. Some typical hazards that may be suitable include, but not limited to, the following: within enclosures such as rooms, walls, enclosed machines, containers, storage tanks and bins. For enclosed electrical hazards such as transformers, control cubicles, switchboards, circuit breakers and rotating equipment. For enclosed flammable liquid or gas storage and processing areas. For engines using flammable fuels. For electronic hazards such as computers, data processing equipment, control room, telecommunication facilities, subfloors and other concealed spaces. Other high-value assets. The main benefits of a gas suppression system are as follows. Safety. A clean agent fire suppression system can be installed for both occupied and unoccupied rooms. In combination with its quick extinguishing and people-safe features, this system makes a strong case for protecting the most valuable resources, the employees. Waterless protection. The clean agents stored in the cylinders flood the room as a gas that is harmless to both the occupants and equipment. This means it will not damage electronics, files or irreplaceable collectibles. This also means that there is usually very little cleanup or residue after the fire has been put out. Fast-acting protection. The system reacts within seconds to extinguish a fire. It will diffuse the fire quickly and also minimize the amount of soot and smoke that fills a room during a fire. Concentrated fire damage. Because clean agent systems are so fast-acting, damage from fire is usually limited to the specific machine or area that caught flame. Minimized downtime. With a clean agent fire suppression system, there should be a little downtime for getting the business back in action. The fire should be detected and extinguished within seconds. There is no residue of water damage to clean up, and the fire damage should be contained to a small space. Environmentally friendly. Clean agent systems are safe for the environment and have minimal, if not zero, ozone depletion potential. Let's now see how the gas suppression systems work. Gas suppression systems are generally used in enclosed spaces. The fire extinguishing action relies on the principle of breaking the fire tetrahedron, that is, remove one component of the tetrahedron. This is achieved in one of the following ways. Dilution of the oxygen content, less than approximately 20%, for example, CO2, energen, etc. Inhibition of free radicals which are necessary for the combustion process to continue, for example, HFCs, NOVEC 1230 and HCFCs, NAFS111. Cooling of the fuel below its ignition temperature, for example, FM200, NOVEC 1230, etc. Let's now see the working principle of gas-based fire suppression system with the help of an animation. When a gas-based fire suppression system is installed, cylinders containing the clean agent, such as FM200 or CO2, are stored separately from the protected area. They are connected to the protected spaces through a piping network that connects to nozzles, spaced out in a manner to cover the entire protected space and also ensure adequate distribution of the agent throughout the protected space. When heat or smoke is detected, an electronic signal is sent to the control unit to send the clean agent gas through the cylinders and piping network. In order to ensure the gas is not released on a false alarm, usually a double knock or a cross-zoning system of detection is used to release the agent. In this system, the protected space is divided into multiple zones, each having one or more detectors. The suppression system is activated only when at least one detector each in two different zones are activated. Hence, the name double knock. Typically, when the first detector is activated, an alarm is sounded, and it is only when another detector in a different zone is activated that the gas release is initiated. Usually, a time delay is also built into the system so that the gas is released 60 to 180 seconds after the second detector activation. This gives adequate time for verifying that a fire actually exists and also for evacuating the occupants from the protected space. An emergency stop switch is provided near the protected space to abort the gas release if so required. Once the clean agent reaches the room in which a fire has been detected, Usually in less than 10 seconds, the nozzles will open and deflector shields can direct the agent towards a particular fire-filled zone. As the clean agent floods the room, the oxygen content is diluted enough to stop the fire and prevent combustion. This system can be a life and asset saver for the data center or archive library to limit the damage to the equipment and prevent the spread of a fire. With technological advancements, the control unit for the clean agent fire suppression system can optimize the pipe valves to only send the clean agent directly to the hazardous zone. These systems also can be integrated to close vents and doors to prevent the spread of fire and even turn off electrical equipment. Now let's look at the various components of a gas suppression system. Let's begin with agent storage cylinders. Agent storage containers are stored under pressure in one or more cylinders, depending on the volume of the protected space, located as close as possible to the enclosure being protected. There is a master cylinder which is connected to the triggering mechanism and a pilot pipe which will trigger the other cylinders in the bank. Non-return valves are fitted in the case of multiple cylinder configuration manifold to prevent backflow of the agent and also for maintenance purposes. Manifolds may be used to join the discharge pipes of two or more cylinders to enable discharge through a single pipeline to the discharge nozzles. The next component is discharge piping. Discharge piping is a piping network which connects the storage container or a manifold to discharge nozzles on the other end. Next are the detecting devices. Regular smoke detectors in a cross-zone system can be used for detection of fire and initiation of the suppressing system. It could also comprise of a smoke detector and another detection system like VESDA. Next are the sounding devices. Sounding devices can be audio, visual or olfactory. However, there should be two types of alerts being provided, one for the initial detection and other for impending discharge. Next is the actuating device. Actuating device is a solenoid-operated valve, is normally used for actuating the system and release the agent. The control panel processes the detection signals from the detectors and operates the solenoid valve, which in turn results in releasing of the gas from the cylinder or manifold into the protected space. Lastly, let's look at the control panel. The control panel is the one which monitors the status of the system and the detecting devices. It processes the signals received from the detectors and also initiates the notifying devices as well as the release of the agent. In addition, it may also be integrated with the building fire control panel and either jointly or independently initiate the closure of dampers, stopping of AHUs, shut down critical equipment, etc. There are various clean agent fire suppression systems or gas suppression systems used in the market. Please take a moment to review this list. Let's see what synthetic gas suppression agents are. Synthetic gas suppression agents are manufactured as chemical compounds that act on the combustion process to disrupt the uninhibited production of free radicals in the burning zone. It should be noted that while the extinguishing concentration of these gases required to extinguish fire are relatively low, their byproducts may have health outcomes for humans exposed to the gas and discharge process. Examples of these gases are FM200, NAFS3, Novic 1230 and the like. Now let's look at gas inerting fire suppression agents. Gas inerting fire suppression agents are those that are either natural or manufactured combination gases that reduce the oxygen content in an enclosure to a level where the combustion process can no longer continue. It should be noted that the concentration of these gases, except energen, required to extinguish fire are reduced to a level where there is insufficient oxygen to sustain human life. Examples of these gases are nitrogen, carbon dioxide, energen, argonite, and the like. Lastly, let's look at aerosol fire suppression agents. Aerosol fire suppression agents are those that produce an extinguishing chemical gas by themselves undergoing a combustion process. The extinguishing agent produced is chemically incompatible with humans. It should be noted that these agents are very combustible in their normal state and, when involved in fire, increases its intensity. It should also be noted that the products of aerosol generation are a dry chemical powder along with CO2 and N2, which are very hot when discharged from the generator canister. An example of this agent is pyrogen and the like. Let's now look at the ways to test the effectiveness of a gaseous fire suppression system. To ensure the effectiveness of a gaseous fire suppression system, testing the integrity of the room is vital to ensure the protected area is well sealed and the gaseous agent won't escape, causing the fire to possibly reignite. Room integrity testing is environmentally friendly and the service is repeatable, allowing the room to be tested at any time. For example, following any changes made to the protected area. For any gaseous fire suppression installation to be effective, the designed extinguishing agent concentration must first be achieved and then maintained. In order to achieve this, the protected area must be adequately sealed. Integrity testing calculates the leak tightness of a room and predicts how long it would take for the extinguishing agent concentration to fall. The test equipment comprises of variable speed fans, expandable door panels, pressure gauges, and a dedicated portable computer. If the test area fails to satisfy the requirements, a detailed survey is carried out noting the leakage areas so that remedial sealing works can be carried out. Now let's look at the water mist systems. Water mist is a versatile and highly efficient firefighting medium. What differentiates water mist from traditional water-based systems is its reduced droplet size. When a droplet of water vaporizes, it expands by some 1,600 times. Because heat absorption is a function of surface area and not volume, smaller droplets mean more surface area and therefore faster heat absorption. A water mist system is a fire protection system which uses very fine water sprays, that is water mist. These small water droplets allow the water mist to control, suppress or extinguish fires by cooling both the flame and surrounding gases by evaporation, displacing oxygen by evaporation, attenuating radiant heat by the small droplets themselves. The effectiveness of a water mist system in fire suppression depends on its spray characteristics, which include the droplet size distribution, flux density, and spray dynamics with respect to the fire scenario, such as the shielding of the fuel, fire size, and ventilation conditions. The use of water mist fire suppression when compared to the use of gaseous agents and traditional sprinkler systems has revealed advantages such as immediate activation, high efficiency in the suppression of a wide variety of fires, minimized water damage, environmentally sound characteristics, no toxic problems. Now, let's look at the advantages of water mist systems. Quick firefighting. As water mist both cools the fire and removes the oxygen, it results in quicker firefighting. Due to the cooling effect of water mist, reignition is avoided. The water mist system is ready for reuse immediately after a fire. Less damage. Water damage is kept at a minimum due to the low water consumption of the high pressure water mist system. This system can be deployed instantly, resulting in less damage. Using only pure water, water mist system uses demineralized water to provide the best possible protection of equipment and human lives. Reduced downtime. The reduced amount of damage often means less downtime, resulting in much lower costs. There's no need to fill up cylinders, thus saving expensive refilling time and overall costs. No need for extra installations. The pump unit takes up little space and needs no special room or safe storage. Easy and fast installation is possible due to small pipe sizes and low system weight. Now let's look at the working principle of water mist systems. Let's begin with the evaporative cooling animation. Water absorbs heat when it evaporates. It's basic physics. Water requires more energy to be in the state of a gas than it does to be in liquid form. So, when it evaporates, it actually uses or absorbs energy in the form of heat from the air. Ever notice that you get a chill for a little while after you get out of the pool, even on a warm day? Why is it cooler being outside of the water than in it? It's the evaporation going on. As the water evaporates, it makes both the water and air around your skin cooler. Now let's see what is high pressure misting. Misting uses the same principle, only without the wetness. Most of the time, wetness is a problem on patios, floors, tables or people. That's where the pressure comes in. If the water is pressurized enough using a high pressure misting pump, a fine enough mist can be created that completely evaporates into the air almost instantly. When that air is introduced into the space, it physically takes heat from the air with every tiny droplet that evaporates. Thus, imagine millions of droplets per second can really do a lot of cooling. With a misting pump producing 1000 psi in pressure, this is the powerful cooling one will get. Let's now see what are the various components of water mist systems. They are nozzles, special gas and water piping, distribution blocks, stainless steel pipe, fittings, electric pump unit, diesel pump unit, pre-engineered cylinder units self-contained. There is no need for external water or power supply. The top manufacturers of gas suppression systems are FirePro, UTC, Siemens, New Age Firefighting Services. The top manufacturers of water mist systems are Tyco Services, Danfoss, FirePro. Now let's look at the maintenance checklist for gas suppression systems. The list below represents the key steps while inspecting a typical clean agent system. Check all initiating devices and verify time delays for system discharge. Ensure releasing device activates properly. Verify abort device and manual release functionality. Check weight and/or pressure of agent containers. Verify the orientation of all discharge pipe fittings and nozzles. Perform enclosure integrity test. Check batteries and signal. Verify as build drawing and flow calculations. The pre-maintenance activity checklist shall be followed. Pre-maintenance alarm isolation. Pre-maintenance gas discharge isolation. Place system inhibited warning tags on equipment. Maintenance activities are to be carried out in accordance with the standard in place for the area or the manufacturer's maintenance schedule where no overriding standard is in place in the area. These activities shall include carry out maintenance functions routine in accordance with an approved system checklist. Report any defects or malfunctions, arrange rectification. Check date of next cylinder pressure test and alert the building manager if within 3 months. Complete maintenance records and checklist. The post-maintenance activity checklist shall be followed. Reinstate normal gas discharge function. Reinstate normal alarm functions. Remove system inhibited warning tags on equipment. Visually check the system status on local and central fire alarm control panels. The maintenance checklist for water mist systems is divided into daily, monthly, half-yearly and yearly. Let's see what these are. Daily. Inspection of abnormal indication of control panels. Monthly. Inspection for pump and motor operation. checks for wire disconnection and lamp test of control panels. Half-yearly, check for alarms. Yearly, overhaul of section valves and water pumps. Check for clogging of water mist nozzle. Inspection for abnormal indications. Inspect and monitor the condition of control panel daily for power supply, damage of lamp, button, switch, etc. Observe for any abnormal noise. Inspection of water pump and motor. Monthly and normal operation of pumps and motors should be checked regularly. In order that pump operation test is carried out, the discharge valve of the pump to be closed and pump drain valve to be opened. The inspection point is to check whether water pressure complies with pump specification and lies in the characteristic curve. Check for any abnormal noise or leakages from the pump and associated pipeline system. Also, check for the suction and discharge pressures while pump is in test operation. Now let's see what the maintenance checklists are. Regular testing and inspection daily checks. Checks to ensure system is operating normally. Rectify and record any faults found. Weekly tests. Checks to ensure signal to monitoring station are functioning. Check battery and voltage conditions. Rectify and record any faults. Monthly tests. Simulate fire and fault conditions on all zones. Check that power supply, indicator, alarm outputs, etc. are operating correctly. Rectify and record any faults. Yearly tests. All monthly tests. Test interlocking circuits to ancillary equipment. Check and cleaning of dirty detectors. Rectify and record any faults. Due to the criticality of the equipment, considering the valuable information or items in the critical rooms, it is essential that the systems are maintained in 100% operational availability status at all times. Let's look at some of the key points to remember. 100% uptime of equipment. Regular inspection of the system. 100% compliance with the maintenance schedule. Regular housekeeping in the equipment room. Prevent inadvertent operation of the system. Now let's look at the business impact due to non-operational fire suppression system. Fire can impact a business in the following ways: major infrastructure and stock loss, lost productivity, psychological impact on occupants, financial losses, fatalities and injuries, staff unemployment, impact on reputation. Now let's look at the top issues and troubleshooting tips. They are: overpressure generated by a dry extinguisher causes problem. Noise generated by dry extinguisher causes problem. What can be done to avoid potential problems? There are 3 areas where measures can be taken: on the side of the hard disk drives, on the side of the extinguishing systems and their alarming devices, and at the point where they come together, especially tests and test releases. Select less sensitive HDDs or other less noise sensitive data storage technologies. Minimize direct exposure of the HDDs to the sources of noise. Use technologies like fault-tolerant RAID systems to better immunize systems. Work on less noisy system concepts. Be aware that testing warning systems might influence performance. Congratulations! You have now completed this e-module on Fire Systems Part 4. In this e-module, you learned the following: Introduction to gas fire suppression and water mist systems, gas fire systems, water mist systems, original equipment manufacturers OEMs, maintenance checklists, service levels to be maintained, business impact, top 5 issues or troubleshooting ideas,